my friends, we're doing 2 sections today, all right? But here's basically the highlight. We are solving quadratic equations. Quick sidebar. When you see an equation that looks like this, what type of equation is that? Linear. Because what's the highest degree? 1. All right? So anytime that you have an equation where the highest degree is 1, that's called a linear equation. It's what we've been doing a lot of our stuff. But anytime that you get an equation, all of a sudden it's no longer linear. We call that what when we have a square? Quadratic. It's a quadratic equation. And we're going to be working with those. So when we have this, and I'm going to make sure, I just literally reiterated that, but I'm going to make sure I put it in the right notes so it matches the filled in stuff. Here we go. We need to remember that with a quadratic equation, you're going to have a variable with a degree of 2. So that's another reason why we practice degrees. Guys, do you think we're going to solve equations that are cubic? Yeah. We're going to use all of those skills. So we're going to solve equations that have a 5th degree, a 7th degree, because we have those basic skills that will be able to help us do this. Now, these should be, and I'm saying this out of love, this is supposed to be reviewed. So if you love algebra, this is your moment, okay? But we got to make sure that we have it. So what are the 4 main ways of solving a quadratic equation algebraically? All right? First method, factoring. And we're going to be doing that today. All right? That's one of the methods we're doing. The other one is taking a square root. You have to be really careful when you use this method, because if you don't do it right, you lose one of your answers. So you have to be very careful. So we're going to be taking a square root. Everyone's favorite method, and I'm saying this tongue-in-cheek, guys, this is not true, that you work with is called completing the square. Now, this is the one that people use the least, and then all of a sudden it comes back to hurt them when they're in pre-calculus, and they have to use completing the square to write equations for conic equations like parabolas, circles, ellipses, hyperbolas. You have to be able to know this process. So it's actually a good skill to make sure you know. And then everyone's favorite method, though, I'd probably say this is everyone's second favorite method, is going to be what? The quadratic formula. So all of those are very helpful. Now, few things you need to remember. When we are solving equations by factoring, we use this property called the zero product property. Now, what does product mean? Multiplication. So what does zero mean? The answer is what? 0. So if I know that I am multiplying 2 things together to equal to 0, what do you know about at least one of them?
0.
It's equal to 0. It has to be 0, right? Because 0 times anything is what? 0. Now, could the other one be 0?
Yes.
Yes. Could they both be 0?
Yes.
Yes, but we're going to use that property to be able to figure it out. But here's the key thing. To do the zero product property, your equation has to equal what, my friends? It has to equal 0. Oh, I clicked on that thing again, didn't I? All right, how do I fix it? You guys remember? Remember how I always click on this in your class only. I always do this. Which one does it get out of there so I can change it? So it will work. It's not going to let me do it. Nope. It's not going to do that.
Are you trying to get a highlighter?
I'm trying to get it out. I just don't want it to even be on. I know, I'm trying to figure this out on this one. Where was, oh wait, exit edit drawing. There it was. Ah, there we go. Ah, every time. And it's always your class period too. It's awesome. All right. If it's not equal to 0, I don't even want to talk to you about how to solve this. it have to equal 0 so we can use the zero product property. But you also have to know the rules of factoring. Guys, quick review of rules of factoring. What's the number one thing you always look for? Oh, we still have to know greatest common factor. What is the second thing that we always do with factoring? Don't we count the terms? Oh, yeah. And then we sit there and we look. How many terms do we have? Do we have 2 terms? Then we look to see if it's a quadratic or not, correct? Then we look to say, oh, if it does it have 3 terms? And then we use trial and error. Or a quadratic can still have 4 terms with it. And could we maybe possibly do factoring by grouping? But it does not matter if you're solving this unless stuff is equal to 0. So a few things you need to know when you're working on these. I'm going to talk you through and then we're just going to write a little checklist for you guys for when you're working on these problems. Okay, first things first. Is this a quadratic equation? Yes. How did you know? Because it's squared. Then you ask yourself, all right, it's a quadratic equation. I'm supposed to solve this using factoring. So in order to use it factoring, it has to be set equal to 0. So then that's the next thing you ask yourself. Is it set equal to 0? All right, so are we good? All right, so when you're doing solving by factoring, the first thing you should do is set it equal to 0. What we love is when it's already what? Set equal to 0. Then you sit there and do your normal factoring stuff. Guys, do I have a greatest common factor for this? No, it shouldn't be. Guys, I'm going to need you to be mature. That sound's going to come up all the time. I want everyone focused. Are you guys able to do that? Okay, thank you. All right, so when you're working with this, there is no greatest common factor. So now what do we do? Now it's time for us to sit there and count the terms. How many terms do we have? 3, okay? So we know if it's 3 terms, it is going to be in the fact that we're going to use trial and error. Now, here's the other thing that I would do if I was personally factoring. I would try to always make sure my leading coefficient, remember that's the number in front of the square, is going to be positive because it makes factoring way easier. So you make sure you have one. Okay, guys, what are the signs that go on the inside? Plus and a minus, correct? Factors of 3x squared. 3x and x. Great. Factors of 7. Gotta love prime numbers. 1 and 7. Should I put the 7 here? And 1 there? Was that a good choice on my part? No, why? Yeah, so this would be here, a positive 7x. And that is going to be a negative 3x. What does that give us? If I add them together. It's a positive 4x. Is that what we're looking for? No, we're looking for a negative 20x. So first thing we're going to do is we're going to switch. We're going to go 1 and 7. Now is it correct? Yeah, because we have 3 times a negative 7. That's a negative 21. Inside we have a positive 1x. Does that give us a negative 20x? Great. So now that we have it factored, set each one equal to 0. So we go 3x plus 1 is equal to 0. We go x minus 7 is equal to 0. And then here's one of those things. Don't do too much in your head, especially on the first one, because this is when people flip things over, they lose track of their signs. Take the time to actually solve. And for a few of you, this means doing this because I'm telling you, division is the hardest one for you all. X equals a negative 1/3, and then I add 7 to both sides. X equals 7. So our two answers are x equals a negative 1/3, x is equal to 7. So what are the actual steps of this? First things first. Step 1, set it equal to 0. Step 2, if it's not in this form, rewrite it in the form ax squared plus bx plus c, aka put it in standard form, correct? Okay, is what we're asking you to do. Write it in standard form. And then set it equal to what? 0. That's how it should look. Quadratics, descending order of degrees when you're doing it. Then what do you do next? Factor using trial and error after you check for what? After looking for what? For GCF. Because, hey, sometimes we don't think it's a quadratic equation, but maybe I can factor a variable out. All of a sudden, then we have quadratics we can work with. And then, when you are done, last step, set each factor equal to 0 and solve. Now, some things you need to know about me. Am I kind of a control freak when it comes to math? Yes. So, here's where I'm going to be controlling. You cannot solve unless there's what type of sign? Equal sign. Isn't that the same thing as what we talked about before our quiz? Like, what's the difference between simplifying and solving? To solve, you must have an equal sign. So, I need everyone to look at me right now. If you drop your equal sign and all of a sudden go from here to here, I don't believe you. Why are you setting it to equal to 0 if there's no equal to what? 0. Stay in the habit of always writing it down. Look at me right now. I don't care if Miss Patterson takes off for it or not. I will. Show your work correctly. Be mathematically correct. You can't just drop equal signs and add equal signs whenever you want it. Keep up when there's an equation. Are you guys with me on that? Simple as that. All right, good. Let's look at the next example and see if we got this down. Okay, when we look at, we see x squared plus 18 equals 9x. Is that a linear equation? What's the signal that's not a linear equation? The square. Okay. So then you go, okay, what next? Yeah, I'm going to set it equal to 0, and I think we can basically do steps 1 and 2 together. Because if we're working with this, if I'm setting this equal to 0, I want to keep my leading coefficient positive, and I want to write it in standard form. So we're going to go x squared minus 9x plus 18 is equal to 0. Now, what do we ask ourselves again? Is there a what? Is there a greatest common factor? What do you guys tell me?
Nope.
No. All right. So it's 3 terms. Notice I just put the brackets down like we normally do when we're factor. Set it equal to 0. Looking at the n sign, what does that tell me about my 2 signs? They're both the same, and they're both going to be what?
Negative.
Right on. How do we know they're both negative? Because of what's right in front. So if it's plus at the end, it's either going to be both subtraction or both addition. Okay, I love factors. This is one's nice and easy, guys. What's the factors of x squared? X and x. All right, I think we've got this one down. Factors of 18.
6 and 3.
All right. Are you correct? What should you do? Check. Isn't this the same thing we've always do with factoring? Notice we check because do you really want to solve a whole equation wrong because you didn't check? No, I'm going to stop. Negative 6x plus a negative 3x, is that equal to negative 9x? Great. Now, make sure you get your 2 separate equations. X minus 6 is equal to 0. X minus 3 is equal to 0. X is going to equal what?
6 and 3.
Yep. And X will equal 3. You have both of your answers. Was that so hard? The answer is no. And I know it sounds really flippant, but it's not. Especially if you're pretty decent at factoring. It's hard if you're what at with factoring. That it makes it a lot harder to do. Now let's look at the next equation. Most people look at this and go, I can't solve this. It's not linear. It's not a quadratic. But before you throw it out, why don't we use factoring to our advantage, correct? So I'm still solving by factoring. So no matter what type of equation you have, if you're solving by factoring, set it equal to what?
0.
Thank you. So when we look at this one, I'm going to move the 6x over. So I got 3x cubed plus 3x squared minus 6x is equal to
0.
0. Okay. What's the first thing? By the way, most of you do decent with this, but still a habit we got to get into. What is the greatest common factor in this case?
3x.
Thank you. So we got 3x. What gets left inside the parentheses if we factor out a 3x?
X squared.
Plus x.
Minus 2.
Oh, looking familiar now? Okay, excellent when we are working with it. So now we keep going and like, can we factor further? And guess what the answer is? Yes. But notice, did the equal 0 ever go away? And does the greatest common factor go away? This is the reason why I wanted you guys to get in the habit of always carrying that greatest common factor down and not waiting till the last moment to do it. Because that's when you forget. You could lose an answer when you're actually solving an equation. All right, what are our signs on the inside? Yeah, we got a plus and a minus. Well, I love factors of x squared. What do we got, guys? And I love factors of 2. Prime numbers are God's gift to mankind in math. What do we got? Where should the 1 go? Where should the 2 go?
Plus 1 minus 2.
Positive what? 2 minus 1. Double check. Positive 2x, negative 1x. Does that give us a positive 1 when we combine them? Yeah. Okay. Now, does the zero product property happen if I have 3 factors multiplying together to equal 0? Yeah, think about it. If I have 3 things multiplying together to equal 0, doesn't one of them have to be at least 0? Could all 3 be? Could 2 of them be? Are you seeing like, yeah, the product property still works. So we go 3x is equal to 0. We're going to go x plus 2 is equal to 0. And guess what we're going to have here? X minus 1 is equal to 0. Guess what? Hasn't gone away yet. And equals to 0. On the first one, guys, 3x is equal to 0. What do I divide both sides by? X is equal to 0. Answer numero uno. Next one. X plus 2 is equal to 0. What should our answer be for that one? All right, x equals negative 2. Then we have here x minus 1 is equal to 0. What should x equal? Okay, now here's a question. How many answers do I have?
3.
What was the degree of my equation?
3. Oh, hey, that's kind of cool.
Now, here's what that tells you, just so you know. That says you have a possibility of 3 real number solutions. There's also a possibility you don't have that many. But it lets you know if you're on the right track or not. So if you do get 3, you're like, oh, that's possible. So that's a good thing. So think about it. When you have a linear equation, how many answers do you get? 1. When you have an equation like 3x equals 5, what's the degree of x? How many solutions do you get? So when I have something that's squared, what do we have? How many possible solutions? Notice I said how many possible? 2.
3.
But it lets you know that that's the case when you have the fact it's squared. All right, now let's look at the next one. It says solve x squared minus 4 is equal to 0. Okay? Now guys, is there a greatest common factor? Notice I didn't even ask you to set it equal to 0 because what is it? Equal to 0 already. Is there a greatest common factor? No. How many terms do you see? Huh. What do I do? What is it? What is that called? A difference of squares? Because if I have 2 perfect square numbers with a subtraction sign, it's called difference of squares. So we go x, we go plus, minus, and then we take the square root of 4, which is what? 2. So we get x plus 2 is equal to 0. X minus 2 is equal to 0. Do not skip this step. We get x is equal to negative 2. X is equal to positive 2. Now, did any of you think, I think I learned a different method than this in order to solve? Any of you remember doing a different method than this, maybe, if you're solving equations? Okay. Here's another method, and we're going to actually talk about it on the top of the next notes, because we're doing both days' worth of notes. Are you guys with me on that? Because there's 2 of them. They're not hard. They go hand in hand. Because you have seen this, what? Before. Okay. Now, there is another method, and it's called the square root method. Remember, that's one of the methods that we said that you would use. But you have to be good with simplifying radicals. Another reason why we maybe learned simplifying radicals before this. So when we're doing this, the square root method says if you can get a squared by itself, you can use the square root method to solve. So would you agree with me? I can just add the 4 over. Right? Now, how do you get rid of something that's being squared? Oh, you take the square root of it. Now I want you to think about something for a moment. When we take the square root of something that is being squared and it comes out odd, what do we use? What's the square root of 4, guys? That's the absolute value of x is equal to. Which means you get x is equal to a positive 2 or x could equal a what? Because absolute value of a negative 2 is what? Negative 2. Now, most of you didn't learn it this way. Most of you learned this. If you showed this step, what you would do instead, you go the square root of x squared equals plus or minus the square root of 4. Then we go, oh yeah, the square root of x squared is what? X. But doesn't the plus or minus do the same thing that the absolute value sign does? So this would be plus or minus 2. Oh, wait. I get 2 different answers. All right, you guys remember seeing the square root method a little bit now? Probably more like on what we did on the right. But the fact is, there's a reason why we learned how to do the absolute value with anything with the squares, or to the index being an even number was for this. So that's another way of doing this one. I'll be honest with you. I always think factoring first. If the original equation is x squared equals 4, of course I'm not going to change sides. I'm going to take the square root of both sides. But if it was x squared minus 4 is equal to 0, it's actually just as fast to factor. So making sure that you have that. Guys, that's your first set of the notes. Okay? So I'm going to stop this here, but then we're going to go into lesson 1.4b. So I'm going to do the other